Hi everyone, myself Mrs. S. Nusrath Najeeba, Assistant Professor, Department of Computer Science SF, the Standard Fireworks Rajaratnam College for Women, Sivahasi. In this video lesson, we are going to learn about relational models in DBMS. These are the contents we are going to learn today. First of all, we are going to see the introduction and key terms and types of keys. After that, we are going to see the characteristics of a relation model in DBMS and constraints. Finally, the anomalies in a relational model in DBMS. Let's see through the introduction. The relational model organizes data using tables, that is relations, consisting of rows and columns. The relational model represents how data is stored and managed in relational databases where data is organized into tables, each known as relation. Each row of a table represents an entity or record, and each column represents a particular attribute of that entity. The relational model transforms conceptual designs from ER diagrams into implementable structures. These structures are used in relational database systems like Oracle, SQL, and MySQL. The key terms in a relationship model are attribute, relational schema, tuple, relation instance, degree, cardinality, and null values. Let's see it clearly one by one. Attribute. Attribute are the properties that define an entity. Relation schema. A relation schema defines the structure of the relation and represents the name of the relation with its attributes. And tuple. A tuple represents a row in a relationship. Each tuple contains a set of attribute values that describe a particular entity. Relation instance. The set of tuples of a relation at a particular instance of time is called a relation instance. It can change whenever there is an insertion, deletion, or update in the database. Degree. It represents the number of attributes in the relation. And cardinality represents the number of tuples in a relation. Null values, the value which is not known or unavailable is called a null value. It is represented by null. Let's see an example for this. This is an example table for the key terms in relationship model. In this, roll number, name, city, phone, age, these are the domains. And here roll number is the primary key. We are going to see the keys in our next slides. And the relation name is student, that is the table name is student. Here roll number, name, city, phone, the elements in that are the attributes. In this we are having 5 columns. So the degree of the table is 5. And the cardinality is number of tuples. Here we are having 4 records. So the cardinality of the table is 4. Next, types of keys. We are having 5 different types of keys. The first one is primary key, second one is candidate key, and the next one is super key, fourth one is the foreign key, the final one is the composite key. Let's see it one by one. Primary key. A primary key uniquely identifies each tuple in a relation. It must contain unique values and cannot have null values. Candidate key. It is a key that represents a set of attributes that can uniquely identify a tuple in a relation. Next, super key. It is also a set of attributes that can uniquely identify a tuple. Foreign key. It is an attribute in one relation that refers to the primary key of another relation. And the final one is composite key. Composite key is formed by combining 2 or more attributes to uniquely identify a tuple. Next, we are going to see about the relational model notations. Relational schema R of a degree n is denoted by R of A1, A2 up to AN. Uppercase letters Q, R, S denote relation names. Lowercase letters Q, R, S denote relation state. Letter sets T, U, V denote tuples. The name of a relation schema such as students also indicates the current set of tuples in that relation. In general, the name of a relation schema such as student also indicates the current set of tuples in that relation. An attribute A can be qualified with a relation name R to which it belongs to by using the dot notation. Here we are noted that R dot A. And n tuple T in a relation R is represented as T equal to V1, V2 up to Vn, where Vi is the value corresponding to the attribute Ai. The value Vi for attribute Ai in the tuple T can be accessed using T of Ai or T dot Ai. Next, we are going to see about the characteristics of a relational model. We are having 8 characteristics. The first one is data representation. Data is organized in tables, that is relations, with rows, that is tuples, representing records and columns, that is the attributes, representing data fields. The second characteristic is the atomic values. Each attribute in a table contains atomic values, meaning no multi-valued or nested data is allowed in a single cell. The third characteristic is the unique keys. Every table has a primary key to uniquely identify each record, ensuring no duplicate rows. The fourth characteristic is the attribute domain. Each attribute has a defined domain specifying the valid data types and constraints for the values it can hold. Next is data independence. The model ensures logical and physical data independence, allowing changes in the data schema without affecting the application layer. The next is relational operations. Supports operations like selection, projection, join, union and intersection. These are the relational algebra concepts enabling powerful data retrieval manipulation. Next one is data consistency. Ensures data consistency through constraints, reducing redundancy and anomalies. Next one is set based representation. Tables in the relational model are treated as sets and operations follow mathematical set theory principles. These are the 8 characteristics of the relational model. Data representation, atomic values, unique keys, attribute domain, data independence, relational operations, data consistency, set based representation. Next, constraints in the relational model. While designing the relational model, we define some condition which must hold for data present in the database are called constraints. These constraints are checked before performing any operation, that is insertion, deletion and updation in the database. If there is a violation of any of the constraint, the operation may fail. The first constraint is the domain constraint. Domain constraint ensure that the value of each attribute A in a tuple must be an atomic value derived from its specified domain A. Next one is the key integrity. Every relation in the database should have at least one set of attributes that defines a tuple uniquely. Third one is the referential integrity constraints, where one attribute of a relation can only take value from another attribute of the same relation or any other relation. It is called referential integrity. Let's see in detail about each of them. The first one is the domain constraint. As we saw before, domain constraint ensures the value of each attribute A in a tuple must be an atomic value derived from its specified domain. Domains are defined by the data types associated with the attributes. Let's see the common data types. First one is numeric types. This includes integers for whole numbers and real numbers, that is float, double precision for decimal value, allowing precise calculation. Second one is the character types consisting of fixed length, that is the char value, and variable length, that is varchar, and text strings for storing text data of various sizes. Next one is the Boolean values, stores true or false values often used for flags or conditional checks in databases. Last one is the specialized types. Specialized types includes types for date, time, timestamp and money, that is also used for precise handling of time related and financial related data. Next, key integrity constraint. As we saw before, every relation in a database should have at least one set of attributes that defines a tuple uniquely. Those set of attributes is called key. For example, we saw a previous table called student. In that, roll number is the key. Since roll number cannot be repeated for two students, we are setting that as a primary key. No two students can have the same roll number. So, a key has two properties. First property is it should be unique for all tuples. The second property is it cannot have null values. Let's see the third constraint, referential integrity constraint. When one attribute of a relation can only take values from another attribute of the same relation or any other relation, it is called referential integrity. The relation which is referencing another relation is called referencing relation, and the relation to which other relation refer to is called referenced relation. Next, we are going to see the anomalies in the relation model. First of all, let's see what is an anomaly. An anomaly is an irregularity or something which deviates from the expected or normal state. While designing databases, we identify three types of anomalies for insert, update and delete. Let's saw it one by one. The first anomaly is insertion anomaly in referencing relation. We can't insert a row in referencing relation if referencing attributes value is not present in the referenced attribute value. Next anomaly is deletion or updation anomaly in referenced relation. We cannot delete or update a row from referenced relation if the value of referenced attribute is used in the value of referencing attribute. These are the basic concepts of a relation model in DBMS. In this video, we saw what is a relation model and what are the key terms in relation model and what are the characteristics of the relation model and what are the constraints can be used in the relation model and what are the anomalies we are going through the relational model. Thank you for watching the video. I hope you learned what is the relation model in DBMS through this video. Happy learning. Thank you.